Are you guys ready? So this seating arrangement is challenging the way I set it up because I should have set it up rotated 90 degrees because now there are two people facing this direction and I just want to talk to you for a couple minutes, and then there are two people facing the wrong direction. You see why this is an issue? Okay? So, no, it's fine the way it is, because you guys are going to, I want you guys to work on this together today. So, if you need to rotate to see me and listen to the words that are coming out of my face, do that now.
Hey. That's true. About numbers.
An art class? No. I can honestly say I've never taken an art class. All the drawing I've done just comes from the teaching.
We draw a plane like 20 times a year.
Yeah. He's circuit.
Well, if you got to do it 5 times a year for 20 years.
Right.
All right, gentlemen, ladies, do me a favor and focus for just a couple minutes. Focus just a couple minutes. So yesterday, you guys did a little lab simulation where you had two charged particles, one of charge Q1, the other of charge Q2. Again, we have no idea what charge is or where it comes from. However, we know that there's a result of the charge. If there's a charged particle or two charged particles, they can interact with each other through a non-contact force. Is that something we seem somehow familiar with? Fine, let's go. Yesterday, you changed 3 variables and decided how they each affect the force. This is the force Q1. This is the force Q2. This is the force distance between them. Yes? All right, try to flash back to yesterday. What kind of relationship did the charge 1 and force have?
Linear.
Linear, thank you. What about charge 2?
Linear.
Also linear. And what about distance?
Inverse square.
Oh, you guys paying attention? I appreciate that. All right. We shoved them all together. We get K, Q1, Q2 all over D squared. And I ask you to go back and solve for K, and you guys got an actual values that sounds good. K is equal to, now grab your Googler and look it up. See what your Googler says. Okay, see what your Googler says. It's called the Coulombs Law constant. It's called the Coulombs Law constant. Jordan, were you waving?
No, I was like acting like I was throwing something.
Did you guys get a value? What's that? 9 times 10 to the 9? Anybody else get 9 times 10 to the 9? Okay? So this is Coulomb's law constant. This is another one of those fundamental constants of the universe. And that's a really cool thing because no matter where you go in the universe, this is always the same. Okay? No matter where you go in the universe, this is always the same. So, the question is, could we calculate, right? Could we calculate the force between two objects if we knew the excess charge on each object and the distance between the two objects? Is that something you could do?
Yeah.
That sound good? That's what you guys are going to have to do. Now, one thing that I find interesting is they knew about coulombs and stuff like that well before, hundreds of years before they knew about protons and electrons. But protons and electrons actually have charge. In your chemistry class, they would have told you that like a proton has like a +1 charge. But +1 what? it's not 1 coulomb, right? They just say, oh, it's +1, but they never tell you +1 what. That's because there's not a what. So what I want to know is what is the charge on a proton in coulombs, and what is the charge on an electron in coulombs? Check your neighbor, or actually check your Googler now. Okay, check your Googler now. You have so many conversations. So you're going to go see. Coulombs Law. Pick up your stuff and go. Okay? I'll let them know you're on your way. What's the charge on an electron? Google will tell you.
Charge particle, right? The electrode. Electricity is stronger than gravity. Electromagnetism is stronger than gravity, right?
Right now, electromagnetism
Is on positive gravity. How does the nucleus stay together?
Yo.
So you got two.
Yeah, what's the charge on a proton in coulombs?
just small enough.
It's pretty close to 0, but it isn't 0. How do they stay together? Yeah, but at that close range, it's a lot more than nothing.
Go. All right, what's the charge on an electron in coulombs?
1.6.
Okay. So 1.6 times 10 to the negative 19 coulombs. Is that a lot of coulombs or a little coulombs?
Like a little.
It's so small. Trust me, they were so shocked, right? First of all, at this point, right, before 1900, they didn't know that there was anything smaller than an atom. And then they're like, maybe there's something smaller. I wonder how small it is. And then they're like, well, we kind of have a sense of what a coulomb is. I wonder if this thing has charge. I wonder how much it is. 1.6 times 10 to the minus 19, is that a small, so small it's almost immeasurable. Does that make sense?
Yeah.
So it's immeasurable. What's the charge on a proton then?
6.25 times 10 to the 18.
Say 1.6 times.
Wait,
The same as the
It says 1 coulomb is equal to 6.25 times 10 to the 18.
Maybe looking like a equation.
Say that again? What did you say? 1 coulomb is equal to what?
Oh, never mind.
No, say it out loud. 1 coulomb is equal to?
1.6 times 10 to the negative 19. But I was looking at it, says 1 coulomb is equal to 6.25 times 10 to the 18 protons worth, or electron worth of charge. But it's not.
Yeah, so this is actually, so if this is the charge on a proton, how many protons would you need to get to 1 coulomb? You would need this many, right? Does that make sense?
Yeah.
So that's what yours. Okay, you guys good with that? What is the mass? What is the mass of a proton and mass of an electron? These have different masses. Please check your Googlers now. What are the mass of a proton and the mass of an electron? Check your Googlers now.
Oh, that's small.
In kilograms, please. In kilograms. Which one do you have?
Electron is 9.1 to the negative 31st.
And what about a proton? Proton mass?
There are things that are smaller than that.
What is it?
It's 1.6 to the negative 27.
1.6 times 10 to the negative 27 kilogram. Yikes. Are these small?
Yeah, they're pretty small.
Smaller,
Are these small amounts?
Yeah.
I think these are very small amounts. So the question is this, okay? The question is this. If we had an actual like electron here, and we had a proton here, would these things attract each other?
Yeah.
Now, do they both have mass? Sure, so is there a gravitational force between them? But do they have electric charge?
Yes.
So is there an electric force between them?
Yes.
I wonder which is more.
Proton has one.
No, I wonder which is more, the gravitational force between them or the electric force between them? You see my question? Right, they both have mass, they're going to pull each other gravitationally. But they both have charge, they're going to pull each other electrically. So I wonder which is more. Is that the question, is that number 2? Oh, number 2 says the force between two electrons is, oh, I don't like that one. A common, let's do number 4. A common isotope of hydrogen, what's an isotope? What's an isotope? Anybody? Bueller? More neutrons? Then what?
Normal. Just charge.
That they're supposed to be.
I think that's an ion.
No, yeah, you're right.
You say then there's
That's
some,
when there's more no, I don't know.
More
I'm
electrons.
pretty sure isotopes were like, you know how you like gave that average before?
Yeah.
0.01? It's like how they got that average, which is like hydrogen might have like 2 protons, I mean 2 neutrons, while another hydrogen might only have 1.
hydrogen doesn't have any protons, or any neutrons.
Deuterium, 1 proton and 1 neutron.
A what?
Deuterium, it's a form of hydrogen. It is 1 proton and 1 neutron.
Well, now I think you're just making stuff up. All right.
I am in intro to organic chem. We're using that like right now.
I'm an intro to organic chemistry.
Okay.
I know what's up. All right. So hydrogen contains a proton and electron separated. Oh, here we go. Ready? This is number 4. A common isotope of hydrogen contains a proton and electron separated by about 5.0 times 10^11 meters. Ooh. Mass of the, how come you have a different mass of a proton than I do?
What? It's only 0.1 off.
No, we'll just pretend they're right. Okay. Fantastic. Here's what I want you to do.
They're both
Okay.
0.1 off.
If you missed the day we learned to use our calculators, or I forgot to do it in here, we're going to do it right now. Are you ready?
With the E.
Okay, yeah. Did we do that in here?
Yeah.
Okay, you got to use the EE. Don't use the times 10 raised. It's just going to, right? It's not going to take you to the promised land. Okay?
What it does.
106. Hi. Oh, he needs to see one of the assistant principals. So he, I filled out a little referral. So he needs to see one of those. Go ahead. All right, thank you. All right, you guys ready? All right, so I want you guys, you got about a half an hour, okay? You got about a half an hour. I want you to plow through this, okay? I want you to plow through this. And I want you to get to number 4. That's an important one, all right? I will be monitoring your progress. Work hard now. Let's go. Do not divide and conquer. Work together. Liam, you are the big winner today. Sermon does not have your copy. I don't know. Something. Oh, she does have my copy.
Yeah, please.
There are 3 pages.